Summation notation. Nubtation. Okay. What summation notation means? It means you're going to add a bunch of numbers together. It's a lot of writing. It's kind of annoying, kind of like statistics. This number right here is the start. And this number right here is the finish. This right here, that's the rule. Okay. And this E thing, this sigma, it's a capital sigma, that is telling you that this is a summation notation. This is a series. It's a rule for a series. And so, let's do it. First I plug in 1, so I get 3 times 1. Plus. And then I plug in 2. 3 times 2. Plus. Then I plug in 3. 3 times 3. Plus. And then I plug in 4. Plus. And then I plug in 5. And then I'm done. How come I stop at 5? That's what it tells me to finish at. So I do this rule 5 times. 1, 2, 3, 4, 5. Then, so we get 3 plus 6 plus 9 plus 12 plus 15.
Yes.
So, wait. Before we add these together, do you guys see the 3, 6, 9, 12, 15? Yes. Do you guys see the pattern with those? What's the pattern? What's happening every time?
Trace.
Yeah, these are all multiples of 3, right? And it's increasing by 3 every single time. If you just had 3, 6, 9, 12, 15, that would be called an arithmetic sequence because there's a common difference. My common difference is positive 3. I know I'm giving you guys too much right now because this is actually 11 too, but this is a series. A series is adding all the sequence numbers together. Adding the sequence together. Okay, anyway, whatever. So we get 9 and 9, that's 18, plus 12 plus 15. So that would be, okay, thank you. I didn't really want to do it in my head. I hope you're right. Are you right? Oh, yeah, you are right. Good job. Because that's 30 and then, okay. All right. And I still did my head, yeah, because I don't trust you. All right. So, all right, so can you guys try this one? There's not as many terms. Go. Okay, I'm going to go a little faster on this one. I'm going to plug in 3 first. So that's going to be 1 plus 9. And then plus, and then I'm going to plug in 4. I'm going to get 1 plus 16. Plus, and then I'm going to plug in 5. So that would be 1 plus 25. Plus, and then I'm going to plug in 6. That's 1 plus 36. How many numbers did I get? 4. And we went from 3 to 6. Some of you guys say right away, oh, that means there's going to be 3 terms. No, you have to count the 3. So there's 4 terms. So it goes 10 plus 17 plus 26 plus 37. All right, so what did you guys get when you added those up? 90? 90? I don't want to add it together. Am I wrong? Are you wrong? Don't be jerks. Okay. It's 90. Okay. All right, look at this one. Let's use blue. Okay, so there's a factorial on this one. It's going to get hideous. And we have 9 terms. What are we plugging in first?
0.
And where are we ending? 8. So it goes like this. It goes 1, 0 factorial times 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial. Oh, this is nasty. Bam. Okay, yeah. Now, let me make comments really quick. 0 factorial is always 1, which is kind of weird. That's a number theory thing. You just have to accept it right now. Factorial is in the multiplicative universe, and the identity number in the multiplicative universe is 1. So this is 1. I know. So that's a 1. This is a 1. That one's a 2. This one's a 6. This would be 4 times 3 times 2, which would be, what's 4 times 3 times 2?
24.
24. Okay, so this is getting really big, right? So we got a 1 plus a 1, and then we got plus a 1/2. Then we got plus a, what's the next? 1 over 6. And then, so this goes on. And the denominator is getting bigger and bigger and bigger. The question is, will we ever reach another number? Like, what is 1 plus 1 plus 1/2, plus 1/6. Like, what is that number gonna become? If we just keep going. Guys, I'm not gonna do it, but I'll show you the answer. So here you go, and then you get this. What is that number? Yeah. Someone else called it out already. It's E. It's E. E is a famous number, guys. This is equal to E.